Hi everyone, let's solve this problem. LRU cache. Design a data structure that follows the constraints of least recently used cache. Implement the LRU cache class. LRU cache int capacity initializes the LRU cache with positive size capacity. So whenever they give us LRU cache and they'll give us a size, we will put the limit of size for our cache. That means if we have like size of 2, we will allow only 2 elements in that cache. So that's the requirement here. And int get int of key, so return the value of the key if key exists, otherwise return -1. So let's say for example in our cache, if the but let's say in case of get, they are passing us a key. If that key is present, we will return its value. If not, we will return -1. Void put int key int value, update the value of the key if the key exists. So if the key already exists in our cache, we will update the value, otherwise add the key value pair to the cache. If the number of keys exceeds the capacity from this operation, evict the least recently used key. Okay, the functions get and put must each run in big O of 1 or average time complexity. So this problem can be solved in multiple ways, but we are going to solve it using a doubly linked list. I'll explain here using the diagrams. So for this, we will be using doubly linked list plus cache. Cache is nothing but our map. These are the two things. Why do we need a map? In order to put and get the values in big O of 1. So that is the requirement for map. Now let me explain you doubly linked list. So let's say I have a linked list which is pointing in just a single direction. We can iterate from head towards the right side of it, but we will never be able to iterate from right to left. So that is possible using a doubly linked list. So every node will have a previous and next. So in case of this node, it will be null. The previous of head node will be null, and the tail node will be null as well. Next of the tail node will be null. So given at any point of time, I can traverse towards any direction which I want, left and right basically. So yeah, this is a doubly linked list. Now let us also solve this problem using the doubly linked list and the cache. So initially let me create 2 dummy nodes. This is to represent most recently used node, and left is used for least recently used. So any node which is on the left is like least recently used, any node towards the right will be most recently used, and we will not do any operations on left and right. These are just dummy nodes for easy moving between the nodes. These are dummy nodes. Okay, now let's try, and we also have a cache. We have a key for hash or the map. We have a key and value, right? So that is the key value pairs, and I have only size of 2. Maximum size of the cache is 2, because LRU cache is going to like have the limit of 2 here. So we are going to initialize our map with size 2. Now let's understand the next step. So LRU cache initialization is done. We are going to put. So when we are going to have a put in this operation, they have given us 1, 1. So whenever we have a put operation, we will first check if the key is already present. There is no key present with 1. Key is nothing. This is key and this is value. Key is 1. So do we have any key which is present in our map? No. So what are we going to do? We are going to insert key and we are going to create a node. Like I mentioned, all the insertions will be happening towards the most recently used. So anything coming up new will be on the most recently used side. So we will be inserting a node, And one more thing before we insert, if there are only these two dummy nodes, in that case our dummy left dot next will be right, right dot previous will be left. So this connection is already there. And now I'm going to insert 1 comma 1. So let's say I'm going to insert 1 comma 1. In this case, once I insert a node, what should happen? My node dot next should point to the right node, and right dot previous should point to my node. And similarly, left dot next should be pointing to my node, and node dot previous should be pointing to left. This is the insertion, and the value will be pointing to this node. So just to show, this node is pointing to this node. So whenever we have a key that is pointing to this node, we have the link to that. Now once put is done, let's move on to the next step. There is a one more put operation. So do we have two key in our hash map? No. So we are going to insert key and we are going to create a node, and any node will be inserted towards the right. So we are going to create a node 2 and map our pointers. I will be showing in detail how are we going to map these pointers, but for now understand this. And we have a operation of 2 comma 2. This is also done. Now we have a operation of get. We are asking for get and they are giving us the key. So do we have that key in our hash map? Yes. One more thing, when we when we have this one in our hash map, what will we do? We will return we have the node here, so we have to return node dot value. Okay, since we are storing our node, we will return node dot value. Node dot value is nothing but 1, so we are returning 1. And this is not okay, node structure is nothing but key comma value. So this is the node structure which we are maintaining in our hash map. And once we get the value of this is nothing but it is recently accessed. That means we have to change the position of 1 because it should be most recently used. So in that case, what will we do is first delete our node and insert towards the right of it. And obviously we will be having these pointers pointing to these things. Okay, this is done, get is done. Now we have to put. Now we got 3 comma 3, but if you see, our cache size is already 2. That means we have reached our maximum capacity. So once this is capacity is reached, what we have to do? We have to delete the least recently used. How do we get that? We do have the access from the left pointer. So left pointer's next node will always be the least recently used value. So what we should do? We should delete this. Before inserting anything, we should delete this. So I'm going to delete it. And what should I do? I have to also remove it from my cache set. So this is done. Once this is done, what should I do? I have to create a node 3 comma 3. Create a node 3 comma 3 and key will be 3. I will make it clean. So we had previously 1 comma 1 which was pointing to this, and this was pointing to this after the deletion of 2 node. So now when I am inserting 3 comma 3, what should I have to do is I have to create 3 comma 3 and I will be pointing my pointers to the previous and next nodes accordingly. Once this is done, obviously this 3 is pointing to this 3 node, and once put is done, now we have a get. For get, we have 2, but 2 is not present in our hash map. That means we have to return -1. This is done. So now again we got a put 4 comma 4. So among like we know that deletion should happen least recently used on the left. So left dot next will be least recently used. So I will be deleting the node first. Once I delete the node, I will also delete it in this case. Now we deleted because we do not have enough space in our hash map, or the capacity has been crossed. So now I will be having a 4 comma 4. But where should I insert that? I should be inserting towards the right side. So in this case, let me just make it more cleaner. So it was 3 comma 3. 3 comma 3 will be here, and my 4 will be here, and my 3 will be here, and I will be pointing these nodes to this. This is done. 4 is also updated. Now I have get of 1. 1 is not present, so I will be returning -1. Now get of 3. So once I get 3, I have the node 3, so I will be returning get of 3, and node dot value is 3 in this case. So this is key, this is value, so I will be returning 3. But once I get the node value, this is the most frequently used, right? So there will be 4 comma 4 and 3 comma 3. So I'm just moving it to the, basically I'll be deleting the node and inserting towards the right side of it. So that is how I'm going to maintain it, and I will be pointing my nodes back. Once this is done, next we have get 4. 4 is again, it's present, we will return key comma value, so we will be just returning the value 4. 4 is the answer here. And now this is, because this is the like recently accessed value, again we have to move the pointer. So what will I do? I will delete 4, insert 4 towards the right side, change, when I'm inserting and deleting, the pointers are auto updated as per our code. So this is how it looks. Sorry, this particular node link should be towards the dummy. So this is how it looks. So we have solved it all. Now let's try to code it up. So before we do anything, we will have to define the node structure. So node equal to function of, we will just get the key and value. So when we get this, we will initialize our key with the value, key value provided value, and then like I mentioned, this will have a previous and next node. So both of them currently will be pointing to null when we are creating a node. So once we get the LRU cache, what are we doing? So whenever we are initializing this, we will have max capacity is capacity. We are initializing the value, and we have to also maintain our cache. So it will be a map, and as I mentioned, left will be a dummy node. So we will be creating with key comma value as 0 comma 0. This should not matter. And right will be new node of 0 comma 0, and this dot left dot next will be pointing to this dot right, and this dot right dot previous will be pointing to this dot left. So let me explain what all we have done so far. So we have just created our map, we have created our left, right, and pointed it to the right directions, and the next will be null, the previous will be null. This is because we are initializing our any node when we create, it will be previous and okay, this should be next should be null. So this is what we have done so far. Now let's try to do this. And so if this dot cache dot has key, if the key is present, then we will return some value, otherwise we will return -1, which is also given in the problem statement. So if the value key is present in the cache, what are we going to do? Okay, first we will do the put implementation, then we'll come to get, so that it's easier to understand. So we got put of 1,1. When we get put 1,1, first we will, any which ways we have to insert the node. In that case, what we'll do, we will create a new node of key comma value we will be passing to the node. Once we get the node, we will check if this dot cache dot has of key. If it already has a key with this, what should we do? We should just do cache dot set of, first we have to remove whatever is the existing node. We will get the existing node, we will remove the existing node, and then we will also insert the new node, and then we will set cache dot set of key comma new node. That we are going to do. And then we also, and we have to return from here, because we are just updating the key was already existing, we are just updating the node value. So these are the steps we are going to implement, remove and insert in a minute. And now we have to also check if cache dot size is equals to, so if the node is not already existing, if the number of the capacity of our map is equal to the max capacity, that means we do not have any space for the new insertions. In that case, what we have to do, we have to get the LRU least recently used, that is nothing but this dot left dot next. Once we get that this dot left dot next, what should I do? I should remove it, and once I remove it from the list, I also have to remove it delete of LRU dot key. So LRU is nothing but a node has key and value, so I am just taking that key to delete in the hash map as well. If this is done, then what we have to do, we have to, let's say the capacity, okay, let me explain it here. Let's say capacity is reached, what are we doing? We are removing the node from the cache, and also we are going to insert in the list, right? So for that, what should we do? This dot insert of new node, this dot cache dot set of key comma new node after deletion. So deletion happens here. So we are done with the put implementation. Now get. So when we have the key already, what should we do? We should first get the node. Node is nothing but this dot cache dot get of key. I got the node. I have to return node dot value as we discussed, and then I have to move my node to most recently used. In this case, what I have to do, I have to remove my current node and insert it back. All the insertions will happen at the right side, and all the remove node will happen in the left side. So this is the use case. Now we also have to implement a remove and insert. So let me copy this syntax and remove. Yeah, so I will get a node. When I get a node, I will have node dot previous and node dot next. So this is for removing, right? So how are we going to, let me give you an example here. Let's say this is my node and we want to remove this node. This will be previous, this will be next, right? Sorry, this will be next. So in this case, when I am removing this, I also have the previous and next. So I will remove this. Previous dot next will point to next. Next dot previous will point to previous. That is all we have to do, because this is not going to be interrupted either ways, right? Previous dot next equal to next, next dot previous equal to previous. So that is all we have to do. Previous is nothing but like nodes previous, so we got it. Now we are also going to implement the insert part of it. Now let's understand how we can insert it. So let's say this is L, this is R, and there are some nodes here which will be pointed in this fashion. So now let's say I got a node, this is a node. So what should I do? First, this is the previous. So previous is nothing but this dot right dot previous, right? I have previous. Now I have to do previous dot next. Previous dot next equal to node. Node dot previous equal to previous. So node dot previous equal to previous. This is done. Now I have node dot next equal to this dot right, and right dot previous is equals to node. Yes, right? This is how we have to do. Now let me write the same code here. Let previous is equals to this dot right dot previous, and let me get it. Previous dot next equal to node. Node dot previous equal to previous. Node dot next equal to this dot right. This dot right dot previous equal to node, right? We have done with the implementation. Now let's try to run it. Okay, it is running. Now let's submit it. It's done. So one thing you have to keep in mind is that we have to return from here, because if there is a cache, we will just update it and we will not we are not going to go through the next steps. That is all. And the other reason, other thing which you have to remember is that we are maintaining left and right dummy nodes to make our moving between the nodes easier, and we don't really have to handle lot of edge cases. That is one thing. And yeah, that is all. And we are going to do our get. Let's see the time complexity of get and put. So get will be, so if it has a node, we are removing. Removal of node is basically just big O of 1. We are changing these pointers, and insertion is also big O of 1. So it is going to be, overall it was going to be big O of 1, and same thing here. We are not doing any major operations. So it will be big O of 1 and 1. I hope the solution is clear. Thank you.